Hello guys, welcome to my channel Chem Insider. So in today's class we are going to discuss about the first chapter of class 11. So we are starting the class 11 chapters now. So in the class 11 chapter, the first chapter says about the matter, some basic concepts of chemistry. So in that we come across the first topic, matter. So what is a matter? As we all know, matter is something which has mass and occupies some space. So if any substance has mass and occupies space, then that substance is said to be a matter. Okay, so now as we have now until understood that matter can be classified into three states depending upon the physical formation. One is the solid state, liquid state, and the other one is the gaseous state. So matter is classified into three types: solid state, liquid state, and gaseous state. So if we have to discuss about the three states of matter, we have solid, which has interparticular force of attraction in its highest value. That is, the particles present in the solids are attracted with huge value of attraction, and hence they are closely packed, such as like this. This close packing leads them to have a definite shape and definite geometry and volume. So they have definite shape and volume. So we all know that solids have particles arranged closely with one another, hence they have a definite shape and volume. And for those of the liquids, they have a very less interparticular force of attraction, hence they have volume, but they don't have a particular shape. What they do is, if you take a liquid in a container, then the shape of the liquid is what it will be the shape of the container. If you take a container of this type, so if you have filled liquid inside this, so that liquid will hold the shape of the container. If you take this type of a container, then the liquid will hold the shape as that of the container. So that means liquids have definite volume, but they have a shape similar to that of the container in which they are taken. And then for the last one, that is the gases. Gases, they have almost zero interparticular force of attraction, hence they are very loosely packed, which leads them to have no shape and no volume. So they don't have usually no shape, they don't have any shape, they take a shape of the container. And for the sort of volume, they only have volume when they are taken in a container. If you are taken in outside space, they won't have any volume at all. For example, for this you can take a consideration of balloon. You see, if you fill a balloon, it has some amount of mass, that is nothing but because of its volume occupied by the air. Okay, so that air is nothing but a gaseous state. If you observe in this slight open space, you won't feel any opposition or volume felt by the air or a gaseous state of matter. So in case of matter, according to the physical states, we have classified into three types: solid, liquid, and gases. And further, these three states can be interconvertible. That is, solid can be converted to liquid, and further liquid can be converted to solid. Solid can be converted to liquid by heating. If you heat it, it melts down to form liquid, whereas liquid on freezing forms solid. Further, liquid on boiling forms gas, and gas on freezing forms liquid. And further, sometimes solids directly converts to gas, and gas directly converted to solid, that is for the sublimation. So the physical states of matters, that is solid, liquid, gases, and solid have no shape, solid have definite shape and definite volume. Liquids have volume, but they occupy a shape as of that of the container which is taken. As of case of the gases, they don't have particular volume or shape, they hold shape or volume only when they are taken in a container. And further, these three states of matter, solid, liquid, and gases, are interconvertible. That is, solid can be converted to liquid, liquid can be converted to solid, and further liquid can be converted to gas, and gas can be converted to liquid. And in case of sublimation, we get solid directly converted to gas. So this is about the physical states of matter. So what we have discussed in the previous classes and in your class 10, something like that. So if you consider for the higher part of point of view, that is in the case of macroscopic observation, what we do is we classify matter into two types. We classify matter as two types, that is mixture and pure substances. So matters in the macroscopic level are classified into two. It might be either a matter can be either be a mixture or it can either be a pure solid, pure substance. That is, matter can be classified into two. One is mixture. It might be a mixture, or rather it would be a pure substance. A matter can only be either a mixture or a pure substance. And further, these mixtures are classified into two types: homogeneous mixture, homogeneous mixture, and heterogeneous mixture. Heterogeneous mixture. Whereas the pure substances are classified into two. One is element and the other one is compound. Okay, so this is about the classification of matter in the macroscopic level or bulk shapes. So matters can be classified into two. One is a mixture and the other one is pure substance. Further, mixtures are classified into homogeneous mixtures, heterogeneous mixtures, whereas the pure substances are classified into elements or compounds. Now, for the case of mixtures and pure substances, what do you mean by a mixture? If you take a substance such as like a sugar solution or coffee or tea, it contains two substances. One is water and a coffee powder, or water and a tea powder. So a mixture is something which is formed by two different substances. If two or more substances are mixed in any ratio, irrespective of what mass or what volume, if two or more substances are mixed with one another, then the resultant substance is called a mixture. That means a mixture is something which is formed by mixing two or more substances of different characteristics. So mixture is one which is formed by mixing two or more substances of different characteristics. For example, our sugar solution, tea, coffee, such as like that. In that mixtures we have two types. One is a homogeneous mixture and the other one is heterogeneous mixture. So now for the homogeneous mixture are those which have the two or more substances mixed as defined by the mixtures itself. It is a mixture of two or more substance, but it appears to be one on complete conversion. That is, like for example, if you add sugar to water, it almost looks like water itself, but just slight difference will be its density or viscosity depending upon the amount of sugar added. Okay, sugar on added to being water, it forms almost kind of a watery solution. So here what we get is a sugar solution which has uniform distribution. That means a homogeneous mixture is a mixture of two or more substance which on complete conversion gives us a uniform distribution of one substance in the other. So if two or more substances are mixed thoroughly in uniform distribution, then that type of mixture is called sugar solution. That type of a substance is called homogeneous mixtures. For example, our sugar solution. Next, for the heterogeneous mixture, what we find is if two or more substances are mixed in a non-uniform distribution, such as like if you are taking 1 cup of pulses and 2 cup of cereals, it is not a uniform distribution, right? And if you take 3 cups of wheat flour with 1 cup of maida flour, so that will be a heterogeneous mixture. So heterogeneous mixture is one in which two or more substances are mixed with one another in a non-uniform distribution, whereas homogeneous, it is a uniform distribution. Okay, so this is all about mixtures and its two classes, homogeneous and heterogeneous mixtures. Next, for the elements and compounds, What is a pure substance first? So pure substance is one which has actual ratio of composition, whereas in case of mixtures its composition is not fixed. In case of pure substances, its composition is completely fixed in a particular ratio. Like for example, if you consider some mixture of glucose. So glucose has C6H12O6. So here the mixture of carbon, hydrogen and oxygen will always be same if you take glucose here or anywhere. So glucose composition is always the same. So that glucose molecule is a pure substance. Okay. So pure substance is one in which there is a complete fixed ratio of composition. So therefore pure substances are classified into two types. One is an element and the other one is a compound. So what is this element or a compound? So element is something which is found either in its single monoatomic stage or a diatomic stage. So element is the primary atomic particle. Okay, if you find out the periodic table, if you consider about the periodic table, we have 118 elements. So all those elements are of pure substances. Okay, so some of the elements may come across in the natural side as a single atoms, such as for example sodium, potassium, etc. So some of the elements are usually stable in their monoatomic species, whereas some of the elements are usually found in diatomic species, like for example hydrogen molecule. So hydrogen, oxygen, nitrogen, etc. And if you consider some other examples as phosphor, they are found in 4 atomic size, that is tetraatomic. So what is this H2O2, N2 and P4? That is, if a substance is found only in its monoatomic stage, so this is an atom of an element, sodium. So this is a sodium atom of sodium element. This is potassium atom. So whereas this is not an atom, but this is a molecule. So this is a molecule of hydrogen. So this molecule of hydrogen is formed by bonding between two hydrogen atoms. That is, when two or more atoms which are similar in their elemental composition, if two or more atoms of the same element combine with one another, then that is called a molecule of an element. So these H2, O2, N2 and P4, these are all called molecules. These are called molecules and these are called atoms of element. These are atoms of element, whereas these are molecules of certain elements. That is, molecule of hydrogen element, molecule of oxygen element, molecule of nitrogen, molecule of phosphor, whereas this is an atom of element sodium, an atom of sodium element potassium. Okay, so now this is about the atoms or elements. So then what is about the compounds? So as we have discussed in the elements, that we say that if two atoms of same element combine, we take it as a molecule of element. So what happens if two different elements combine? That is, if two atoms of different elements combine, then that gives us a molecule of compound. Like for example, if we consider H with Cl, H and Cl together we call them as HCl, and this is a compound. So here two different atoms of two different elements, two atoms of two different elements are getting combined to form a compound. So this compound is a molecule of compound. So here H and Cl is combined to form HCl. It is a molecule of hydrochloric acid compound. Okay, so elements usually arrive in two parts. One is a single atomic, whereas the other one is molecule, where these molecules are formed by two atoms of same element. Whereas in case of compounds, they arrive in one form, that is mixture of two or more atoms of different elements. So now in this case we have H and Cl. We can also take an example of H2O. If you mix two atoms of hydrogen and one atom of oxygen, we get H2O. Here for every two atoms of hydrogen we use one atom of oxygen. So that is, we are using three atoms of complete compound. So that gives us one molecule of water. So what you have to know about over here is, If you consider the compound composition of the element, molecule of a compound or a molecule of an element, what you observe is they always have a fixed ratio. Okay, so they always have a fixed ratio while they are getting composited. That means the composition of element and compound are always fixed in a certain ratio. That is, if you take water, it has 2:1 ratio of hydrogen with respect to oxygen. That is, 2 atoms of hydrogen reacts with 1 atom of oxygen to form H2O. In case of HCl, 1 atom of hydrogen gets binded with 1 atom of chlorine. In case of ammonia, we use 1 atom of hydrogen, 1 atom of nitrogen and 3 atom of hydrogen to form NH3. So clearly the fixed ratio of composition makes them as a pure substance. They won't have any different composition. If you consider the composition of C6H12O6, we use ratio 1:2:1 with respect to carbon, hydrogen and oxygen. So for every 1 atom of carbon and oxygen, we require 2 atoms of hydrogen in order to form a glucose molecule. So now this is about the classification of mixtures, matters, that is mixture and pure substances. One point you have to remember about is the compounds chemical properties will not be same. Compounds properties will not be same as that of its atomic property. Okay, whereas in case of elements, property of the atoms will be the properties of molecules of its element. If hydrogen is having certain number of property, then the hydrogen molecule will also replicate the same properties. Whereas in case of compounds, the property of hydrogen and chlorine will not decide the property of HCl. So HCl is a different property. For that, if you consider a simple example which we observe in the natural causes in our nature, is hydrogen burns very well with fire. Hydrogen burns with fire, whereas oxygen is used to burn fire, right? Hydrogen burns when ignited, whereas oxygen is used for burning. If you mix those two, hydrogen and oxygen, we get water, which we use it as a fire extinguisher. So hydrogen and oxygen, even though those two are atomically combustible, water, which is formed by hydrogen and oxygen, is not at all combustible, and it puts off the fire. Okay, so that we can, on that note, we can complete this particular matter topic. So this is about the matter topic of our first chapter of class 11, that is classification or the nature of matter and classification of matter in macroscopic level. In the next class, we are going to discuss about the properties and international system of unit measurements. Okay, thank you for watching. If you do like this video, please subscribe and share among your friends in order to them get help of these videos.